Hey everyone, welcome to another session of Ceerazzledazzlephysics. In today's session, we're going to be talking about convection, guys. So put down today's title, it's going to be convection. Hopefully you've watched my previous videos on heat transfer, guys. I've done 2 videos so far. Watch the heat transfer one and the conduction one before watching this one. But don't worry, we'll do a quick recap before we move on. So in the previous videos, I talked about how heat can be transferred. Heat can be transferred via 3 processes. Number 1, conduction. Number 2, convection. Number 3, radiation. Conduction occurs when heat is going to be traveling through solids. So this one is going to be solids. So heat transfer through solids is going to be conduction. Convection, and it is the heat transfer through fluids. So it's the heat transfer through fluids, guys, which is fluids. What are the fluids? It's going to be liquid and gas. So heat transfer through fluids such as liquids and gases. This will be known as convection. And hopefully we can remember that heat always goes from hot to cold. Heat always flows from hot to cold. Okay, let's get straight into it with the following example. So over here I've drawn a gas. Okay, so here's my gas right now. Yes, I've drawn the particles inside a gas. Let's say now we were to heat it up on this side over here. So what happens if we were to heat it up over here? Okay, let's just talk about a region of it. Let's just talk about this region over here. What's going to happen to these particles here? Well, each of these particles is going to gain kinetic energy, and if they gain kinetic energy, they will move away from each other. So this one, let's say it will move away. So it moves over here. They all move away. So they all move, some of them move out. So one of them now goes to there, the other one now goes to there. One of them stays inside, the other one moves over there. Okay? So when the particles gain kinetic energy, they move away. Okay? So when the particles move away, what's happened to the actual air now? What's actually happened to the air? It's something about the density. Well, hopefully before we can see this. Before it looked like the following. So before, yeah, right. So look, I've drawn 2 diagrams now, a before and after bit. So just of that blue bit over here. All right, so before you can see there was quite a bit of particles inside, but now you've heated it up, the particles have moved away. Therefore, the air has now become less dense. So now afterwards, it is now less dense. Yes, so the air becomes less dense. So before it had a higher density, now that region of the air has become less dense now. Right, so now it's become less dense. What will actually happen? Well, this region of air will actually move upwards. So this region, I'm going to put an arrow over here. This region of air will move upwards over here. So there we are. The less dense air will rise upwards. Let's put it down in words though before we move on. So, okay, so from the top, particles gain kinetic energy and move away, but as they move away, the air becomes less dense, guys. So that air becomes less dense, just that region over there. And if it becomes less dense, guys, what's it going to do? Well, it's going to rise upwards. So wonderful. The warm, less dense air rises upwards here. So it now starts to move upwards here. The reason why is because it's less dense than the surrounding. But what about the opposite side now? So now let's just talk about these bits over here. In comparison, this region now, compared to the other region, this bit will be more dense. So we know that the less dense air will rise upwards. The more dense air will the denser air will drop downwards over here. So we have, let's just label this bit here. So wonderful, guys. So as you can see, I've labeled it. We've got the less dense air rising upwards over there, and the opposite side, the more dense air is dropping down. This then forms a nice cycle, guys. This forms a nice cycle, which will be called a convection current. So what happens is obviously this will rise upwards and go over here, and this bit will drop down going over here. So we end up with this nice circle going all the way around here, with which the hot air rises upwards and the cool air dropping down. And this is convection, guys. This is convection. Okay, so don't forget the keywords when explaining the process. So the particles gain kinetic energy and they move away. And as they move away, the air becomes less dense. And therefore, the warm, less dense air rises upwards. And obviously, by symmetry on the opposite side over here, cooler, denser air drops downwards. This therefore causes a convection current to be formed, guys. So the convection current can be formed here. Wonderful stuff. Okay, let's look at it in another example. So that's for a fluid in which it's a gas. What about a liquid? Okay, so here's my next example. This one will be for a liquid. So as you can see, we have an ice cube right now, and we're going to put blue dye into the actual ice cube. So imagine like normal ice cube, but it's now containing blue dye, food coloring inside it. So with color blue. And we place it inside our fish tank over here. And on the opposite side of it, we're going to inject hot Ribena. hot Ribena. Hopefully you know that Ribena is going to be red. So one of them is going to be hot Ribena, the other one's going to be a blue ice cube. What's going to happen? Well, we know that the hot Ribena will heat up the water over here, and therefore causing it to, obviously, become less dense and then rise upwards. There we go, it rises upwards over here. And obviously, the blue ice cube will cool down the water nearby, and therefore it will become more dense, and therefore it will drop down. So as you can see, we then get another convection current being formed over here, which you have the hot air, well, not the hot air, the hot liquid rising upwards, and the cool liquid dropping down. So this is another example of convection, but now it's in a liquid. Okay, so that's for a fish tank, guys. Okay, so test your understanding about convection with the following question. Why is the heating element of a kettle placed at the bottom of the kettle? So why is it that when we give you a kettle, you probably see one in your everyday life, the heating element is at the bottom? Think of the reason why. Right, so you know that the water needs to be heated up, so therefore we place the heating element at the bottom. Why? It can heat up the water from the bottom, which will rise upwards across the whole thing. If you were to place the heater at the top, it would only heat up the water at the top, and none of it beneath it would be heated. So that's the reason why you place the heater at the bottom to heat up the water, which therefore rises upwards. Therefore, the whole thing can become heated. Yeah, and also, guys, you can look at it in the following way. Let's say the heater was placed in the middle right now. Well, it would only heat up the water above it. So the water beneath it, all of this region around here, it would never be heated up because the hot air will rise upwards, it will never drop down. So that's obviously going to be inefficient. So you want your heater to be at the bottom to heat up the water, which will rise upwards and go everywhere. If it's midway, that's where it is. Obviously, it won't heat up all the water. Okay, what about the next scenario then? Okay, so test your understanding. Why do some freezers have the coldest compartment on the top shelf? So why do some freezers, guys, hopefully you've seen them in your house, why do they have the coldest compartment on the top shelf? Think about it. It's something to do with convection. Right, so hopefully you can remember that. You have the coldest part at the top. The reason why is because it will cool all the air underneath it. And obviously this air will then drop down and go through all the other shelves. So the cool air will drop all the way down, cooling all your food inside the refrigerator. That's the reason why. And think about if you draw the reverse scenario. What happens if we put it at the bottom? Right, so as you can see, I've drawn the reverse. Let's say we installed the coldest part at the bottom. Well, obviously the coldest part at the bottom, it would cool only the air near it. And obviously it has nowhere else to drop down, so it wouldn't actually travel across all the other shelves. So your food at the top would start to rot. So that's the key thing here. So you want it to be at the top. The reason why is because the cool air will then flow down, cooling all the other shelves. The cool air will only drop down, it can't go up. And that's it, guys, for another session in Ceerazzle Physics. Let's have another recap right from the top. So right from the top, we said convections are today's title. It's going to be the heat transfer through fluids. And the two fluids we're looking at are going to be liquid and gas. And we did conduction in a previous video. You can watch that in your spare time. Scrolling down, I then drew the following diagram. We said that what happens when you were to heat up a gas in one corner? We know that the particles move away from each other. That air becomes less dense, therefore it rises upwards, guys. So less dense, warm air will rise upwards. And on the opposite side, the cooler, more dense air will drop down. This therefore causes a convection current to be set up. So we get a convection current set up. I didn't put that down here, so this is called a convection current. There we go. The cycle going round. Okay, so then obviously make sure you get the keywords right in here when you're describing the phenomena. Scrolling down, we then said fish tank, guys. We've got the blue ice cube on one side and the hot Ribena on the opposite side. Well, hopefully we know that this will also set up a convection cycle. So not only does it occur in a gas, it also occurs in a liquid. And then last of all, we then give you the example of number one. Why do we have the heater at the bottom of the kettle? It's so that it heats up the water, and therefore the warm water can rise upwards throughout the whole thing. If you put the heater higher up, obviously it won't heat up the water beneath the heater. And then scrolling down, we said that why do we actually have freezers with the coldest unit at the top? The reason why is because it can cool down the air and therefore it drops down across the whole thing. Right, and if we were to put the coolest part of the freezer at the bottom, obviously that cool air will never be able to rise up and obviously refrigerate the rest of your items. And that's it for another session in CeerazzleDazzle Physics. I shall see you next time. Make sure you like and subscribe to all my videos to keep my channel going. Stay cool, people. Ciao, ciao, and goodbye.